Hello all. Now from the job sequencing, here we have 5 jobs, each of which must go through the two machines A and B in the order AB. So processing times in hours are given in the table below. So here we have 5 jobs, 1, 2, 3, 4, 5. Machine A with the processing time of 5, 1, 9, 3, 10, and also machine B. That means here he has given 5 jobs and 2 machines where we have to determine the sequence for the 5 jobs that will minimize the elapsed time. So let us solve this particular problem. So given data, so here the job machine A and machine B. So he has given here 1, 2, 3, 4, 5. So machine A with the processing time 5, 1, 9, 3, 10. Machine B given 2, 6, 7, 8, 4. So here first what we have to find out is the optimal sequence. Optimal sequence. So we have to find the optimal sequence. So the optimal sequence. So in this one, so left side will say A. So how many jobs we have? 1, 2, 3, 4, 5. So we'll have 5 blocks like this. 1, 2, 3, 4, 5. So machine A and machine B. Now in this one, in this processing time, the minimum processing time lies in the machine A under job 2. So machine A, job 2. So the first sequence, job sequence will be here as it is job 2, machine A. So here. So job 2. The second minimum value lies here in the machine B2 where the job 1 is there. So job 1, machine 2, job 1, machine B, job 1, machine B, job 1. Simultaneously 1, 2, 3. 3 lies in the machine A. So job is 4. So 2, 4. After 3 we have 4, that is job 5. So machine B. Next 5 which lies only one left, that is the 3. 5 is there but only one job left, that is the 3. So optimal sequence we have found. Now we have to calculate the time in and time out for machine A and machine B in the sequence of these jobs. So for machine A, so here we will be taking job 2, 4, 3, 5, 1. So time in and time out for machine A. So always remember it starts with the 0. So time in will be always, it starts with the 0 for machine A. So 0 plus 2, time out, job 2, okay, job 2, here listen, job 2, machine A processing time is 1. So timeout will be 1. So for the next job, so 1 plus fourth job. If we take fourth job, machine A processing time is 3. 1 plus 3 becomes 4. In the same way, for third job, it has to start from the 4 plus third job is processing time is 9. 4 plus 9 is 13. For the fifth job, we have 10. So 13 plus 10 will be 23, and 23 for the first job, it is machine A plus 5. 23 plus 5 is 28. So again for machine B, so time in, time out, machine B. Time in and time out for machine B. So here in the machine A, timeout is 1. So for the next machine, time in will be timeout of machine 1. So here time in will be 1, because here timeout is 1. For the machine B, time in will be 1. So machine B second job processing time is 6. So 1 plus 6 will be 7. So immediately 7 plus this value is maximum, so we will be taking the same one. 7 plus fourth job machine B is 8. 7 plus 8 will be 15. Now 15 is greater than 13, so 15 plus third job machine B is processing time is 7. 15 plus 7 is 22. Now here if we observe, 22 is less than the 23. So time in will be 23 here plus here fifth job machine B is 4. So 23 plus 4 will be 27. 28 is greater than 27. So again I will be taking 28 plus job 1 is 2, processing time is 2, 28 plus 2 is 30. So total, this is the total elapsed time. So total elapsed time is 30 hours. Idle time for machine A, idle time for machine A is 0. Idle time for machine B, here if I see, so before the process, so there is 3 hours gap left, so I can take this 3 hours as idle time for the machine B, because 27, 28, 30. Okay, so this is how we solve job sequencing, and we can determine the sequence that will minimize the elapsed time. Thank you.